Hi team, I hope you are well, fine and good. I welcome you all to this another video session. So I think you'll be having a very interesting, things here because we'll be having a discussion on the shadow leak and what actually it is and how actually it works and how the ChatGPT, deep research agent become a bait of this. So let us discuss further, and I hope you will definitely enjoy the session. So please stay tuned and watch. So going to what actually happened, or what is actually the shadow leak is. Okay, in one line if I start saying, okay, so let me read it out to you all, so that you can even have a greater explanation or greater visibility or greater understanding about what actually the shadow leak is. So when we discuss about shadow leak, right, so it is a is a zero click. Okay, shadow leak is a zero click service side indirect prompt injection vulnerability, okay, which is actually been discovered by Radware in OpenAI's ChatGPT deep research agent. Okay, so it is one of the vulnerability, okay, that is actually been discovered inside the ChatGPT deep research agent. Okay, what actually it does is that it would even exfiltrate the sensitive Gmail information or Gmail inbox data to an attacker simply by the agent, okay, reading is specially crafted email. Okay, even no user clicks or visible interaction been required on this. Okay, so this is how or what actually the shadow leak is all about. Okay folks, so then after who discovered it, okay, who actually the main person who actually discovered it. So researcher at Adware, okay, author like Vivi Boy and Gabi, okay, contributed mayo responsible for this disclosure. And this has even been issues to OpenAI. Okay, public write-ups and press coverage followed even too. Okay, so what are the different affected components or precondition that actually been become a bait of this? The attacker actually targeted the attack targeted ChatGPT deep research agent. Okay, so when the agent one is granted access to an user email or similar structured text sources and is allowed to browse, okay, using the agent any kind of web or execution feature while processing inbox contents. Okay, so then after if we discuss about how the attack works, so we need to understand three main concepts here. So what are the three main concepts? One is indirect prompt injection, or we can even say IPI. So what actually this indirect prompt injection is? So how the attacker become a how the attacker starts doing his initial access on this. So attacker actually sends a normal looking email that is just like how you actually receive in your corporate email boxes, or how actually you receive information in your inbox. It is just like a very formal normal looking email, okay, that actually contains hidden or obstacle instruction in the email's HTML, okay, tiny prompt while on white right layout tricks. Okay, so the human recipient never needs to open or click anything. That is how actually it works. So when we discuss about the second most thing, that is agent injected email. So when asked to research, okay, to summarize by email, the agent follows the hidden instruction because it reads the message on content actually that. Okay, so that is how actually the agent injects works. Then after last is service side exfiltration. The agent actually which has been running on the OpenAI server structured a web request to, okay, to what, to the attacker controlled URL, okay, containing exfiltrated private data. To bypass obvious content filter, the agent is instructed to encode the data, example base 64 we can even say, before sending that. Okay, so the execution layer sees only an encoded string, okay, not a raw PIA personal information, okay, avoiding some lower level checks. Okay, because the request originated from OpenAI's cloud, the leak is visible to endpoint enterprise logs and even we can say local defenses. Okay, so coming to what's why it's notable and why it is very dangerous, we need to understand that. Okay, so Then after we will be having we'll be going through impact examples and timeline of this. Okay, so why it's notable, or we can say why it's we can say why it's notable or why it's very dangerous. So one is zero click. Okay, what is zero click is all about? No user interaction required here. Okay, just receiving the mail is enough. In the agent later inspects the inbox on the user's behavior. That's it. So service side are invisible. So exfiltration happen, okay, from OpenAI cloud server. Okay, organization may have little or even no local forensic evidences to detect or block it. That's how actually the hidden gem is all about. So broader scope, if we start discussing about the broader scope, so any structured text sources, any agent we can even say can read, like Gmail connector documents can be abused with creative prompt injection. So impacted devices, when we discuss about the impact examples or impacted devices, impacted assets, one is exposure of PII or personal information, internal legal HR emails, confidential deal information, credential and other material that are even being potentially available in your inbox. So potential regulatory and compliance sequences, like GDPR, CCPA, SEC, constructural breach and downstream frauds are one of the biggest impact of this example. So coming to the timeline or disclosure or patch status. So Radware actually published the technical disclosure around 18 September 2025 and disclosed to OpenAI, and the OpenAI confirmed and patched it. The vulnerability shortly thereafter, public reporting indicates OpenAI moved quickly to fix it. Okay, reported date September 19 to 2025. Radware reported no evidences of active in the wild exploitation prior to patching. Okay, so this is the timeline or the disclosure of the patch information that has been disclosed. Okay, coming to the examples of bypass, okay, trick or high level, we can even say the actually the model is convinced to perform a harmless looking transformation. Example, we can even say base 64 encoded extracted values and then append that encoded string as a parameter in an individual web call. Okay, since encoding happened before all lower level checks, okay, the actual execution or the actual execution layer started receiving only a benign encoded payloads and forwarded it. Okay, this is the core evasion that made the exfiltration reliable. Okay, so how actually the trick of bypassing, it is very high level and very it looks very convenient for the attacker to get your information without doing without users doing anything. Okay, so detection standard, so network EDR, our endpoint detection systems and the devices which are being loaded into our endpoint devices, tools like would not see the sensitive content because the outbound request originated from OpenAI server, not the user endpoint. Again, the user endpoint is not become a bait, the OpenAI agent become a bait of that. So content exfiltrated or filters that actually inspect the raw ongoing request and may even see only encoded obfuscational data. Okay, the attacker even therefore defend signature based or endpoint only monitoring. So what are the different sort of recommendation or mitigation steps or individual or organization can even take in the form of immediate or short term? One is restrict the connectors. We can restrict the connectors. That is one of the action items that we can take. Okay, unlink or avoid connecting high sensitive email accounts to agentic AI features unless absolutely necessary. So disable deep research agent autonomous features for users who do not need them, especially for accounts with access to sensitive data. Along with that, enforce least privilege, only grant the minimal scope. Okay, send and prefer service accounts with limited access. Enable strong authentication and monitoring. Okay, turn on MFA for accounts and monitor for unusual third-party auth grants. Along with that, log and alert for external activity. So where possible, monitor for unusual open AI API connected activity or unexpected auth token grant. Okay, so when we start noting, because exfiltration originated from OpenAI server, enterprise border logs may not show content, but they can show connector, uh, you know, any kind of suspicious activity in the connector uses or patterns. Okay, so coming to the long term perspective, and the last thing is all about OpenAI vendors hardening the agent, against indirect prompt injection at a semantic safeguard that actually detects encoding exfiltration pattern, and avoid enterprise audit trials exposing agent execution, which actually been required. So adverse disclosure call this out. OpenAI patch the immediate issue and will need to literate. Are there indicators? Is there any indicator? And as of now, right, the public reporting focus on technical rather than simple IOC based exfiltration level, little local trace. Okay, the country, observable signs all about unusual earth or connectors grants. Along with that, unexpected agentic summarized by inbox, task, or outbound request to known third-party agents in the endpoint originating from the OpenAI domains. Along with that, no forensic details been observed as per the different spokespersons from Radware technical briefs. Okay, so this is all about today's video analysis, folks. I hope you have a great session over here. So please do a subscription to this channel and get the latest info regarding any cyber affairs.